Hi, I'm Barry Brown. I'm CEO of Beltscan Systems. I'm also head of R&D here. And today I'd like to introduce you to our latest product. It's the BeltGuard RCT Alpha Plus. Let's have a look.
The RCT Alpha Plus is a device which was created to measure the remaining cover thickness of a steel cord conveyor belt. It does it non-contact and with the belt running in normal production. Usually it is the carry or top cover that is being measured. This is the basic system, which employs 3 sensors which are strategically located across the belt width. This basic system can be expanded to 6 sensors if necessary. However, we've been using a single sensor version of the RCT since 2012 and are totally convinced that 3 sensors, if located correctly across the belt width, will provide all the information needed to predict end of life in the belt through loss of cover material. Here is an example of the cover thickness data from a single sensor, taken over 1.5 revolutions of a conveyor, confirming the data repeats accurately. The outside sensors are located in line with the skirts at the load point or points, and the third sensor is located above the lateral position in the belt where the highest normal rate of wear occurs based on cover profile measurements taken over time or taken at the time of commissioning. The sensors are pre-calibrated prior to shipping, and this calibration is confirmed during commissioning. The sensors are typically located above the tail pulley of the conveyor, where the belt is flat, clean and virtually flap-free. At this location, the carry cover must be facing up. If it is not the case, the system can be installed above a drive pulley, where the carry cover is always facing up. The heart of the system is this sensor. The sensor contains 2 probes, one of which is measuring the distance to the belt surface and the other is measuring the distance to the tops of the ropes or cords. It's very important to remember that the thickness value in millimeters after processing is the absolute finite cover thickness remaining in the belting at the location being measured and is totally independent of belt total thickness, pulley cover thickness, or worn pulley lagging, etc. The sensor is measuring a strip of belt approximately 30 millimeters wide. Currently, the sensors are located in their parked position, safely away from the running belt surface. However, when actually measuring cover thickness, each sensor needs to be much closer to the belt. The bottom face of the sensor is located 30 millimeters above the tops of the ropes during a scan. This relocation or deployment is achieved using computer control of an electric actuator located on the mount. It may be required to scan the skirt areas much more frequently than the third sensor, so there is provision to deploy each sensor individually. Because the sensors are quite close to the surface of the belt, which may be running at 7 meters per second or more, provision is made to allow them to swing up and away in the event of a collision. This is done automatically, and a collision alarm is generated and that sensor is parked and the scan aborted. Each sensor is suspended from a length of standard 50mm scaffolding pipe via its slotted mount, which provides adjustment on all axes. It is very important during a scan to know where the belt is located laterally on the structure at any instant. And this is achieved by using a pair of ultrasonic non-contact lateral position indicators, or LPIs, targeted against the belt edges at the scanning location. It is equally important to know where along the endless belt each cover thickness record is located in reference to a point on the belt, usually a known splice. This is achieved using a pair of simple tacho generators. The tacho generators consist of a magnetically sensitive probe and a small permanent button magnet, which is attached to the end disc of a properly driven idler roller. It is usually a return idler roller. A pair of tachos is used to provide 100% redundancy where idler rollers are replaced but the magnet is not. Each system comes fitted with a high-resolution IP camera, which is very useful both in the scanning process and for troubleshooting. The sensors, LPIs and tachos are wired back to a termination enclosure, which is typically located close to the scanning location but outside the guarded area. The cable run length from the termination enclosure to the various active elements should be kept to a minimum, and the longest cable run is typically 30 to 50 meters. The main electrical enclosure, or MEE, is located at some convenient distance and typically mounts off the conveyor stringers. The system is easy to install and commissioning is supervised by a factory-trained product specialist. It is a very low-maintenance system with low-pressure water washdowns the only regular maintenance requirement. The MEE contains all of the electronics required to control the system. The electronic platform is National Instruments standard industrial grade and the software platform is LabVIEW. The RCT Alpha Plus is a software-based system and therefore is extremely flexible. More detailed information about the software is available. Access to the system is via a Windows-based application or web interface. Other industry standards of connection are available upon request. Software and firmware upgrades are done remotely, and there is provision for simple on-site recalibration if the need arises. Remote technical support is via the internet through a local area network or mobile broadband service provider. For more information on the RCT Alpha Plus or our other products, please visit www.beltscan.com or contact your local Beltscan systems agent.